So my screen is visible to you, right?
Yeah, right.
Yes. Okay. So in second year and in first year we studied mechanics, right? In second year we studied strength of materials, and in third year we studied design of machine elements. Also, we studied heat transfer, then theory of machines and dynamics as well. But we were taking simple cases or simple geometries in all of this, okay, or simple cases in all of these subjects. But in real world, the problems will be much more complex, and we have to modify them or approximate them to simple cases if you want to solve them, right? With our understanding of design of machine elements or the subjects, whatever we have learned in until the third year, okay. But in real world, the problems will be much more complex, and we cannot go with the analytical methods because that will be taking longer time. Another thing, that will be very much complex with the analytical methods. So we have a numerical methods or the experimental methods. Okay, in numerical methods, we will try to approximate the engineering problem, and we will have some assumptions and we will solve the problems. Okay, in experimental methods, we will build the prototypes. We will actually build the prototypes, and then we will have the whatever the loading condition or whatever the environmental condition are there, we will apply that on these prototypes and we will test them. So testing, you might have studied. So we used to do some tensile test, torsion test, this kind of test. Okay, this was for the simple geometries. But in industry, if you have built some product and you want to check whether that will survive or for the given loading condition, then you will have to test it. Okay, so that will come under the experimental methods. Okay, so each of these method, analytical method, numerical method, and experimental method, have their own advantages and disadvantages, or their area of application. If you have simple problems, then you can always go with the analytical methods. If you have more complex problems, then you need numerical methods. And so you always have to, once the prototype is ready, you always have to test some of the samples so that you can compare our numerical results with the experimental results, and we can check whether our prototype or the product is suitable for the application. Okay, so analytical methods will give you 100% accurate results, but this method, they will be applicable to only simple geometries. Okay, the next thing, numerical methods will give you the approximate results. Now it is not needed to have prototype already. You will just model it in modeling software, any modeling software, maybe SolidWorks, CATIA, Creo. In this, you will be modeling it. Then you will be analyzing it. Okay, the analysis type will be depend on what kind of analysis you want to do. So these results, they depend on many factors. So if you analyze it and you have the solution, you cannot blindly say that our analysis results are correct. So you need to have good understanding of your engineering subjects. Then only you can infer whatever we are saying from the software, that is correct. Okay, so you should be able to compare software results with our understanding, engineering judgment. Okay, now these numerical methods have different type of method. First is finite element method that we will be studying in this course. Then we have second boundary element methods that are used for acoustics and NVH type of problems. We have third type of method that is finite volume method. The CFD softwares are based on this method, finite volume method. The last method is finite difference method. So for the thermal and fluid flow analysis, we use finite difference method. Okay. Now, linear, nonlinear analysis, buckling analysis, thermal, and dynamic and fatigue analysis. These kind of problems we will be solving with finite element method or finite element analysis. Okay. Now, we will be using different softwares. We will be looking what kind of softwares we will be using for the finite element analysis. Now, in experimental methods, what we will be doing, we will have to test 3 to 4 prototypes, and then we can say that this product is suitable for the whatever need or the whatever requirement. Okay. We'll be measuring different strains from the strain gauges. Then we can measure strains from photoelasticity. Then we might have to measure the vibrations as well from vibration testing. Then we can also measure, we can have sensors for measurement of temperature, and we can also measure from some of the equipments like pressure. We can also do the fatigue testing to check what is the life under the fatigue loading condition. So these are the 3 methods with which we can solve any engineering problem. Now, what is finite element analysis or the finite element method? It is a numerical technique for finding approximate solution to boundary value problems or partial differential equation. Okay. In simple terms, we try to divide a complicated problem in small elements, and we have equations for that small elements, and then we combine that all elements to have the solution for the that complicated problem. Now, when should we use the finite element methods? For simple problems, like if you want to analyze a simple bar or beam or shaft, in that case, you can simply do with your strength of materials and design of machinery element knowledge. You don't need the finite element method for simple problems. But whenever the geometries or the structure is complicated, right? So geometry is not like cross section are not simple like circular, square or rectangular or I section. These are not simple cross section, and we have complex cross sections. We have complex assembly. In that case, we will be using finite element analysis. Or in cases where the loadings are not simple. Loadings, by that, what we mean by that, like we studied in song that we have point loads, then uniformly varying loads, uniformly distributed loads, this kind of loads, movement, torque. But in reality, our loadings may have different profile. They may be much more different from this. In that case, we will be going with finite element method. So if the geometry is complex and loadings are complex, and we also have sometimes like material properties are not linear. Whatever we studied in a song, we were using simply like sigma is equal to E into E small a, like capital E into small e, right? So stress upon strain is equal to Young's modulus. So we were assuming that uh, like we were analyzing using the Hooke's law only, right? In the elastic limit only, right? But all the materials may not be showing the simple linear relationship. Okay, so they might be having a non-linear relationship, and in that case, or we might need to analyze some of the problems where we have plastic strains as well. Okay, in that case, we will be using finite element method. So three cases: either your geometry is complex, or loadings are complex, or your material properties are not linear. In that case, we will be going with finite element analysis. Okay. Now, so how does the finite element analysis work? So in the first step, we divide a complex system into different or discretize it in the elements, so different elements, and the connection, the points at which the elements are connected are called nodes, and we generate the mesh. Okay, now this mesh has the material properties and the shape function or the displacement function, that, and we have how this each element will be reacting to the given loading. Now the nodes are like this mesh density depends on the this stress levels in the particular area, or the if that is critical area. In that critical area we will be having high density. If the region is not critical, in that case we will have the lower density of the mesh. So that details we will be seeing in the next chapters, but just to have the understanding. Now we will be uh, solve this mesh. We will have the stiffness matrix for each element, and then we will combine the stiffness matrix for all the elements, and we will solve this equation. Okay, and we will have the we will check the solution or compare the results or the with whatever the understanding we have. Okay. Now, what kind of analysis we can perform with the help of finite element analysis? Yes, we will be sharing the recordings after the lecture, so you can always go through it afterwards, and you can revise it as well. So, what kind of analysis we can do with finite element methods? So, first thing is structural analysis. In structural analysis, we it consists of linear and non-linear models, and in that we try to find these stresses in the given geometry or given structure, and we want to compare the stresses, whether the stresses in the structure are below the allowable limits. The allowable limits may be your yield criteria. That may be your yield criteria. Like if your stresses are below the yield limits, then we can say that our structure is safe, right? So our structure will not fail, or our equipment will not fail if this. We will compare the stresses with the allowable limits. That is the structural analysis. Okay. Sometimes in some of the applications we might have to compare strains. Okay, because if you have a higher strains, then the equipment or the uh, structure may not perform well if you have higher strain. We can take one example of the turbine blades, and in casing and turbine blades we have some clearance, small clearance, and if the turbine blades, when it is revolving, if it after a certain time, if it deforms more, or the strains in that blades are more, then the clearance will be smaller and smaller, and at one time the blades may hit the casing, okay, and that may cause a failure. So in some of the cases, your strains may also be the limiting criteria. So that is structural analysis. And most of the time we perform, like, we always want to have the at least structural analysis for all the application. We always want to check that whether our product is safe for the given loading condition, okay, like it will not fail for the under the given loading condition. So we'll always perform the structural analysis on all the products, okay. Now we have second kind of analysis. Let us say we have uh, equipment, and in that equipment we have some sources of vibration, and that vibration have certain frequency, okay, it is vibrating with some certain frequency, and we know that each geometry has its own natural frequency, right? And we also know that if the excitation frequency, or the applied applied frequency, it matches with the natural frequency of the geometry, then we will have the resonance. And in resonance case, the structure will vibrate with very high magnitude, very high amplitude, right? And it may fail because of this higher resonance case, right? So we always want to avoid this resonance case, and we want to check the natural frequencies of geometry. So we will be performing the vibration analysis to check the natural frequencies and to find the mode shapes, okay. And we will check the what are the natural frequencies and mode shapes, and if our natural frequencies are matching with if any of the our natural frequency is matching with excitation frequency, then we will have to modify our structure so that it does not match with the excitation frequency, okay. So for this to check we don't have the resonance case, we always we have to perform this vibration analysis, okay. So for bridges, most of the machineries which involve some of the vibrations, in that case we perform the vibration analysis. Now the next kind of analysis is fatigue analysis. In the real world case, we have most of the our applications which have the cyclic loading. We don't have the constant or the uh, static loading. By that, what I mean is the load values are varying, or the amount of load which it is under, that varies with respect to time. And in that case, our structure or our equipment or product may fail below our yield value or yield stresses, okay. So if we don't perform the fatigue analysis in this case, and we just have performed our structural analysis, and we are saying that our equipment or product is safe, and in the reality it fails after a certain time, and we will be wondering why it failed, okay. So whenever we have cyclic loading, in that case our structure or equipment may fail, or it fails much below stress values of yield stress or yield strength, okay. So in that case, we want to perform the fatigue analysis and we want to check that for the given loading, given cyclic loading, what is the life of that product. So nowadays, most of the companies give the warranty life for their product, right? So for how many number of cycles it will be uh, it will be it will not fail. Okay, so our structure or equipments will not fail. So that is the fatigue life, okay, for the given loading condition. So next type of analysis is heat transfer analysis. Now we in heat transfer subject we study simple cases where we one dimensional steady state heat transfer. This we study, but in reality this will not be the case. So we might have some of the problems which we have the non-steady or the transit heat transfer. Then we were always assuming that the problems are 1D or the temperature are varying in only one direction. But in reality, that may not be the case, and temperature might vary in all the directions. So in all these cases, whenever we have complexity, then we will be taking the help of heat transfer analysis and using the finite element methods. Okay. Now, how this finite element method will be helping to design machines. Okay. So why is it needed? Actually, the finite element method. So if you consider the earlier cases, let us say 30 years back, whenever any company was launching any of their product, let us say one car company is there and it want to launch its new car. Okay. So in prior to like 20-25 years or 30 years back, the product development time was much higher, or the time difference, the total time required for the launching new product was very much high. And nowadays, if you consider it, the product development time has drastically reduced, right? Now it has how it was possible because of these finite element methods or these tools which we have developed. Okay. Because of these tools, this product development time has been reduced, and we can actually launch our cars every 1 year or every 2 years nowadays. Companies do that. Okay, so that is possible with the help of these financial methods and the modeling softwares. That time has been reduced a lot. Okay, now if you consider the earlier vehicle designs, the vehicles were much more bulkier, right? And uh, currently, the weight of the vehicles are much more reduced, right? Now, all of the companies have very much or high competition between them, right? So, in the same range, we will be having many number of cars available, and because of this high competition, they always want to reduce their price, the product price, and they also want to have the better design. So to reduce the product cost of the uh, vehicle or car, the first thing, the product development cost should be lower, and that will be lower when we can produce that product within short duration of time. And second thing, if if we are using lower and lower material or our like lower amount of material, or if we have lower vehicle weight, right? So we need the optimization. So if some of the components earlier were 100 kgs, now they maybe might be weighing around 50 kgs, and with the same strength or maybe with the more strength. Okay, earlier we have number of materials available, we have good designs available, so they always want to optimize their designs. So for the optimization case, we need FEM. Okay. Also, whenever we have complexity or irregular shaped geometries, in that case we will be needing the FEM. So we can solve solid mechanics, fluid mechanics, chemical these problems, chemical reactions, electromagnetic problems, biomechanics problems, heat transfer and acoustic problems with the finite element method. So we have a lot of application of finite element method, and this is actually a lucrative field whenever for the mechanical engineers currently, and uh, many of us want to go in this field to have better uh, uh, better exposure or the if you want to contribute in a better way as a mechanical engineer. So we have this always, as we say that with the FEM, we will be needing a smaller and smaller duration of time for product development. So we have business advantages. Okay. So we will be, another aim of the finite element method is, let us say if you develop one product and if you want to check that whether that product will survive for the given loading condition, what we will be doing is we will be simply doing the test, okay, for the given loading. But if you do the testing, in that testing the cost involved will be higher, and uh, the product like that testing maybe sometimes will be restrictive testing. So whatever the product we have used for testing, we will not be able to use the same product afterwards. Okay, so cost involved for the testing is higher, and if we always want to reduce the number of testing and redesign cost, so for that case we use finite element methods or FEA. Also, we always want to, before the product is launched, we always want to check where it may fail from the design perspective. So we can have a good understanding of where it may fail, or in which area or at which locations it may fail. So that is also one application. And also in failure analysis, like in if some of the products are actually in application and they have failed, okay, and now the customer has said that he has like he has said that in which condition it failed. Okay, now you collected that product and you are analyzing why it failed. Okay, now you will be going back to the your analysis report and you will be checking that was this the critical area, or where the stresses in this area higher. Okay, we will be checking the location at which location the stresses for the same product were higher. If the location matches, like wherever it has failed and like analysis location, then we can say that okay, our analysis results and these results are matching, and we can modify our design at this location. But what if it doesn't match? Okay, so in this case we may investigate more that what conditions are there uh, which we have not considered in our analysis. Okay, so that in that way for final failure analysis, this finite element analysis may help. Okay. Yeah, so these are few applications of FEA. Now, what are the basic steps involved in FEA? So first we discretize the problem, discretize the geometry. By discretization, we mean we generate the mesh, or then we approximate the function that we want to go with the linear or quadratic. So that kind of function. Okay. Now we form this, like we know that force F is equal to kx for simple spring, right? F is equal to k into x, where k is the stiffness, right? For spring, right? F is equal to kx. So similarly, we also say F is equal to kx for the elements as well, where k is the stiffness metric, okay, and x is the x are the displacement, F is the F are the loads, okay. Uh, so we form first the stiffness matrix, then we combine the stiffness matrix to form the total stiffness matrix. Then we form the element loading matrix, then we form the total loading matrix, and we prepare the equilibrium equation, and then we apply the boundary conditions, and then we solve it to have the nodal displacement and calculate the stress and strain. With examples and with whenever we will be going in details, that will this procedure will be more clear to you. Okay. Now these are the phases in the analysis. Pre-processing. In pre-processing, we will be generating mesh. Then we'll be applying the material properties. We will assign the material properties, and then we will be assigning the boundary condition. In solution, we will be solving that matrix equation. The solution will be and the software, the tools will be doing this solution. We don't have too much doing this, but we have to uh, put efforts in pre-processing. Most of the FEA engineers, their most of the time will be going in pre-processing, like say 60 to 70% time will be going in pre-processing, like generating mesh, assign the material properties, then given the boundary conditions. In solution, we just have to click a button, and the software will be solving it. Now, the last step is where our engineering knowledge is required. Okay, so anyone with the tool, like someone who has like uh, good hands-on experience with the any tool like NCS and Astra, also any software, but he produces the results and he is not able to like tell what these results mean. Okay, so engineering judgment or engineering knowledge is required to tell what the results mean. Okay, or take some have the some uh, uh, verify the our results. So engineering knowledge is required for the in that case. So in post processing, we will be checking whether our solution is correct. Then we will be checking this what are the stress values, displacement, say strains in that, and whether our stresses are below the allowable limits, and which area in which location the stresses are higher, and do we actually think that our analysis is correct, or in this is the area where actually this ratio should be higher. So okay, so in post processing, we will be checking that, and we will be producing the analysis report in this process after the post processing. Now we have some advantages. We can solve easily handle the complex geometries with the help of FEA. We can solve the different number of problems, different type of problems, vibration, heat transfer, fluid. We can have the complex loadings. We can assign the complex condition, like if you have the indeterminate structures in analytically, whenever we want to solve that, it is very much complex. You might be remembering that fix kind of beams. In that case, we wanted to find the reaction and movements at the constant, and it was very much difficult. But with FEA, indeterminate problems can be solved easily. Again, we have the we generally assume the isotropic material properties for our analytical methods. But when we have the orthotropic or anisotropic material properties, that also we can solve with FEA. So by means of orthotropic is like our properties are varying in perpendicular direction. And anisotropic, by means of anisotropic, we mean that our properties are varying in each and every direction. Okay. Also, we can solve the temperature dependent. If you have temperature dependent material properties, or we have plasticity, we want to solve the grip problems or sealing problems, we can use FEA. So these are some of the advantages of FEA, and there are more actually. We can list a more number of advantages as well. But FEA might have some disadvantages as well. Actually, we cannot say that FEA has a disadvantage, but there is always that is from the perspective of the analyst. But whoever is perform the analysis, he has to take care of it. Okay. So we always have to do the different like every time the new problem is there, we have to do the analysis. If the geometry is changed, or the loading condition is changed, or we have the different product, in that case we will have to do the uh, another analysis. So every time we have to do another analysis. So that is one disadvantage. Now sometimes in like model itself, we may have some assumptions and we may have some errors. So there are always errors, and to minimize the analysis time, we always have some assumptions. Now like it is always needed. Like also, if we see the current scenario, so most of the industries, or the most of the FE engineers, they industries are preferring the students, or the candidates who have good understanding of the finite element methods, and so not with the good understanding of this tool. So uh, it is always needed good have needed to have good judgment uh, and good engineering judgment to have consider the good finite element method. Sorry, model. We also need good powerful computers. We need good computation power to solve the FEA problems. Again, analyzing the results is maybe tedious for some of the analysts. There may be errors from the significant digits or rounding of the values. But these are not significant actually. Now these are some of the softwares we use for the FEA, ANSYS, national pattern, then ANISA display. LS-DYNA is a software mostly used for the uh, uh, dynamic analysis, or the explicit dynamics. So for this LS-DYNA is that software, like whenever we have the dynamic problem, so in that case we use the LS-DYNA. Hypermesh is the software whenever we want to generate the mesh. This is the people prefer for the generating mesh, and then generated mesh is then imported into another software for analysis purpose. So CATIA, ProE, SolidWorks. These also have like basic analysis uh, uh, analysis feature available, but most of the people like this softwares CATIA, ProE, SolidWorks, and SolidWorks. These are mainly used for the modeling or the prototype generation. For this software are used for that. So this have feature for analysis, but that analysis is not that much detail as compared to these softwares. So this you can go. You can now this ANSYS. So many product-based companies they use the ANSYS software. Like whenever your number of bodies or the number of geometry is not that much complex or number of bodies are smaller, in that case we go for the ANSYS. Now if for the number of bodies, the parts involved in that assembly are very much higher, then we use the hypermesh and other tools for that case. So that's it for the introduction. We will start the actual syllabus from the next lecture. So if anyone of you have any doubts, you can uh, ask me, or you can ping me in the chat. So is anyone having any doubt? I will be suggesting to take this course because this job, this FEA field gives a good, actually the if you say the mechanical engineers who are getting good salary, so these people are the mostly the finite element analysts. They are working in the FEA field or the design field. So these people get good salary. So I will be suggesting, if you want to have the better career, you can always take this course. So there are some areas like fatigue analysis, creep analysis. So these areas are very good areas where you can have the your research as well. And so many industries want this expertise from this area. And so if you want a good career, you can always learn FEA and FEA tools. You may also actually want ask your seniors that who are getting good amount of money, and which are the areas we should be working. So they will be always telling that you can learn if you want to be in the core field, okay, in the mechanical field. So you can learn FEA. So anyone having any doubts, you can ask. Manoj, Akshay, Vaibhav, Nilkant. Any doubt? Yes or no? You can just ping yes or no. Okay. So most of the people like who are want to do their MTech or post graduation, be it either in uh, a design field or thermal. So they will be like 50% of the time they will be working or studying this FEA. And people with MTech are always preferred in this. Yeah. Yes, Nilkant.
What are the courses we should do for a good designer?
what are the courses which we
we
must?
we should do to being a good designer in future.
Okay. So Nilkant, there are actually two fields, like whenever you go in an industry. So small scale industries, they will have the design engineering people and like only design engineering people, and they will be doing both, like design as well as analysis. So a design engineer is like this they will be actually preparing the model. Model is like they will not be thinking about the whether this will be uh, surviving the actual loading conditions, or they will be just prepare the models. So you can actually you need to have good understanding of the engineering graphics, first thing. And the second thing, for the design engineers, I'm saying you can learn uh, SolidWorks or these tools like SolidWorks or FEA or FEA. So I will be suggesting SolidWorks or the UGNX for the from the current requirement of the industry. So UGNX or SolidWorks, I will be suggesting you to learn. And if you want to go in the analysis field, analysis is like you have to check the like if you consider this structural analysis, you have to check the whether the structure will be safe for the given loads. Okay, so you will be checking the stresses, strains, and so that is the job you will be doing, and you will be comparing the results with the alloyables. So that is the job you will be doing as an analyst. Okay, or the FEA engineer. And if you want to be
Is our any
yes, Nilkant.
is our role in site designing like when you see the sites like any international or national sites which are provided on Google or something that like that, does designer are also work there? Do designers also work there, sir?
Okay. So
Like we see the interface of script bus like nominal interface like script bus.
okay.
It's having the designing element like color matching, any other border like image appearing. uh, are this work can we do from this side?
Yes. Actually, so you are talking from the perspective of website design or something like, and I was talking
Website
from the
designer
perspective.
but from mechanical field,
Yes.
but from mechanical field.
Yeah. There are many people actually who are working in this field. So to have the good user interface, they will be always needing people who have good understanding of this thing. And also one thing, uh, what I want to tell. So yes, so if you want to go in that like, yeah, so there are people needed for the animation. Okay, so in
Animation.
the animation industry, you always need a good designers. Okay, good understanding of designers. Okay,
uh,
so
Likewise my friend is working in animation field. One is at painter side who is doing job on this application like Swift, and
okay,
one is at Roto who is actually cutting that image, and one is painting.
okay.
So that field is related to us or not, sir? Because
Uh,
they have a very different criteria. Like they have to cut all the images, and one is for only painting the other side.
uh, Actually, that job doesn't involve that much of a technical background from the mechanical side. But if you have good interest in that field, that you want to create the good animations, any industry need good animation. Okay, for like advertising purposes or any kind of it. Okay, so they need good animations, and if you have good understanding of this design field as well, it will be always beneficial.
Okay.
Ye- But this design field, whatever I am talking, that they will be needing the good understanding of the engineering graphics, then geometric GD&T, and this field, drawing and all this.
Likewise, in this field, we design mobile elements or such small particles from mobile.
Yes, yes.
Likewise.
So
Thank
for the
you.
mechanical engineering engineers, that most of the jobs for the design engineers are the from automobile industry first thing, then the second aerospace industry, then oil and gas industry, so and the appliances industry. So you need to create the models, then you have to give that models uh, to the analysis people, then they will check whether that they will be surviving that loading condition, and if they survive, then you can produce the drawings, and that drawings will be given to the manufacturing people, and they will be producing the whatever the you have given in the drawings.
Thank you, sir.
Yes. So you can connect with me on WhatsApp as well if you have any doubt. Okay. So thank you. Take care.
Thank you.